This video is topic 3.3 over function notation. For the bell work, we are told that a man bought X boxes of donuts for $3.49 each. He paid with a $50 bill and received the correct amount of change. If he received more than $10 but less than $20, what represents the number of boxes of donuts he could have bought? So this problem is a bit complicated. We know that he paid with a 50 and either got 10, that's not a 10 or $20 back. So two different things we could do here, but the way I'm going to solve it, if he got $10 back, it means he spent a total of $40. If he got $20 back, it means he spent a total of $30. Now what I'm going to do is figure out if he got $3.49 each, how could that make sense? So $3.49 times X would need to be less than or equal to 40. And then 349X could be less than or equal to 30. So for this problem, for both sides, or for both inequalities, I'm going to divide by 349. So if he had $40 divided by 349, he could have bought 11 donuts. And if he had 30, I would divide by 349 on both sides. And X is less than or equal to 8. So somewhere between $8 and $11, so A would be my option. So if he spent $30, the most he could buy would be 8. If he spent $40, then he could get up to 11. So between 8 and 11. So for today, we have a little bit more vocab, some reminder. A function can be a relation with X values and Y values. So a function is a specific type of relation where you have X values and Y values. So this example is like a function machine. We put the domain in, we get the range out. So my domain here is -1, 0, and 1. And remember, domain is our X values. So range, therefore, would be our Y values. Now again, for the table, our X values are given for us, but we need to come find the Y values. In order to find the Y values, we're going to take each piece separately. We're applying it to this rule over here, 2x plus 3, and we're going to plug in 3 different X's. So if I put 3 things into the machine, I should get 3 things out. So for the first Y, 2 times X plus 3, 2 times X plus 3, and 2 times X plus 3. So I'm using that rule, 2x plus 3, and I am plugging in or substituting in an X value. So for the top one, we have 2 times -1. 2 times -1 is -2. -2 plus 3 is 1. 2 times 0 is 0. 0 plus 3 is 3. 2 times 1 is 2 plus 3 is 5. So my range would be 1, 3, and 5. We have 3 separate distinct values that could substitute for my range. To write them as ordered pairs from that table, when X is -1, Y is 1. When X is 0, Y is 3. And when X is 1, Y is 5. So it tells us down here, function notation, the rule y equals 2x plus 3 can also be written as f of x. So instead of y, you have f of x equals 2x plus 3, which tells you which x value to plug into the rule. For example, if you were looking to find f of -1, you would replace x with -1 in the rule. So down here we have f of x equals x squared minus 3. So this is just my rule. They give me the domain, which is 3x values, and I'm just going to plug each of those into the rule. So first, I'm going to plug in -2, and anywhere I see an x, I'm replacing it with -2. Then I'm going to plug in 0. So f of 0, anywhere I see a 0, I'm plugging in. Anywhere I see an x, I'm plugging in a 0. And then I'm going to plug in 2. Anywhere I see an X, I put a 2. Now remember, if I put 3 things in, I should get 3 things out. So for the top part, negative 2 squared is 4. 4 minus 3 is 1. For f of 0, 0 squared is 0 minus 3 is negative 3. On the bottom, 2 squared is 4. 4 minus 3 is 1. So for this one, these are my correct ranges, but they repeat. So when I write my range, I'm just going to have 1 and negative 3. And remember, these are separate, distinct points. So I put them in the little brace. If you can't do the brace, just do the little squigglies. Ooh. For problem 3, we have g of x. Now, g of x is no different than f of x. Sometimes you're going to have multiple functions at the same point, and so it's just a way for them to tell you, use this function or use this function. So again, this is our rule, and we're just going to plug these in. So first I'm going to plug in negative 4. So g of negative 4 would be negative 2 times negative 4. Everything else stays the same. To find g of negative 1, I'm plugging in negative 1. And then to find g of 2, I'm plugging in 2. So I write it all out first, and then I go solve. To solve, I can plug these into the calculator if you aren't super confident in doing it in your head. So negative 2 times negative 4 minus 4 is 4. Negative 2 times negative 1 minus 4 is negative 2. And negative 2 times 2 minus 4 in blue is negative 8. Again, remember these are separate, distinct points, so my range is 4, negative 2, negative 8 with the braces around it. On the back, they ask us to find the values indicated. Now this time, we're still using the same stuff, but instead of having a rule, we have points up here. So the h function has certain points that have been listed. Remember, on the inside is x. So here they're saying x is 6. What is y? So I'm going to go find where is x 6. When x is 6, y is 12. For the second one, x is negative 2 because the inside is x, so go find y. When x is negative 2, y is 6. And on the bottom, x is 8, find y. When x is 8, y is 14. So those problems are like a simple look at what you have, go find what you need. You're not plugging in, you're not really solving anything mathematically. You're just going to look and say, oh, this is what I need. Okay, so on this example, they give us 2 different functions. So this is where those letters really come into play. On problem 5, they want you to use the f function and use the fact that x is negative 2. So the inside tells us what x is, the outside tells us what function we're going to use. So I'm going to use the f function, 2 minus 1.3, and then x is negative 2. And I can plug all of that into my calculator and figure out exactly what it is. 2 minus 1.3 times negative 2 is 4.6. And I can put it here or here. Problem 6 wants me to use the g function when x equals 5. So my g function is 0.25x minus 9.1. So you see I simply took that x and replaced it with 5, and I'm using the g function, not the f function. So in my calculator, 0.25 times 5 squared minus 9.1 is negative 2.85. Now in problem 7, there's two things they want us to use. First, they want us to use the f function when x equals 4, and they want us to use the g function when x equals negative 1, and then add them together. So first I'm going to find f of 4. F of 4 would be 2 minus 1.3 times 4. Let me scoot that up just a little bit. Separate these. All right, so in my calculator, 2 minus 1.3 times 4 is negative 3.2. And then using the g function, g is that 0.25, plugging in negative 1 for x squared minus 9.1. So again, using the g function up here. In my calculator, 0.25 times negative 1 squared, minus 9.1 is negative 8.85. And then remember, they want us to add these. So I'm going to take negative 3.2 and add it to negative 8.85. When I do that, remember I'm typing it in exactly like I see it, I get negative 12.05. So for this one, we are using both functions, plugging in both separate x values, and then adding them together. On the bottom, this one again, they've given us a table instead of points, but anything on the inside is x. X is always on the inside, and they just want us to take it a tiny bit further this time. H of 4, so when x is 4, y is 74, and then they want us to subtract 3 from that. 74 minus 3 is 71. H of x plus 2 for x equals 2. So h of 2 plus 2 would be h of 4. Again, that would be where x equals 4. So h of 4 when x equals 4 would be 74. For the last one, 3 times h of x for x equals 0. So when x equals 0, I'm going to plug that in. So when I go find x of 0, when x is 0, y is negative 10. So I replace h of 0 with negative 10. 3 times negative 10 is negative 30.